Hello everyone, welcome to this lecture video tutorial in the mathematics of the modern world. Enjoy learning. Hello everyone, in this lecture video we will be discussing part 2 of chapter 5 uh, entitled apportionment and voting, as you can see here. So this is part 2. So for the objectives of this lecture, the students are expected to determine the different methods of voting to determine a winner. Just like the what they call this one, the apportionment in part 1, there are uh, 4 methods also in this lecture that we are going to discuss. And also there are uh, 4 criterions for fairness. Okay, this one here, and similar to the topic that we discussed about apportionment, we also have a theorem here, which is what we call the arrows impossibility theorem. In apportionment, we call this as Balanski-Yang impossibility theorem. Okay, so these methods here, different methods, let's see, let's have this one here. We will be discussing about plurality method of voting. Okay, the second one, we will be discussing about Borda count. Okay, Borda count method of voting. Letter C, we will be discussing plurality with elimination. Plurality with elimination. And finally, letter D, we will be discussing about pairwise comparison voting method. Okay, voting method. Okay, these are the 4 methods that we will be discussing in this lecture. Okay, so what is voting? We already know that especially in this country, in the Philippines, we have the right to vote. Okay, so if we live in the democracy, in a democracy, we enjoy the what we call this one, the right to vote. Okay, and then if you notice in the not this election, 2020 election in the US, where Biden and Trump are the candidates for presidency. Before that, Hillary Clinton and Donald Trump, we know, I don't know if you follow that election, the best candidate did not get elected. Why is this? I've searched it in the internet. As you can see here, this one, Hillary Clinton receives 65 million 853,625 votes, while Donald Trump received 62,985,106 votes, which is, as you can see here, uh, you would say, if you are not familiar with voting method, then you would say that Hillary Clinton win the election. But as you can see, Donald Trump was uh, elected as the president in 2016. Okay, so what's the meaning behind this election? Okay, in 2016. Okay, it says here, unfortunately, that is because the plurality voting system works. It is possible to elect someone or pass a proposition that has less than majority support. Okay, and let me point out here this one, majority. Okay, what do we mean by majority? Okay, we will discuss that later. Okay, so in the Philippines, we know that uh, when we elect someone or pass a proposition, then we use this one, popular vote. Okay, the one who will win must have the popular votes. Okay, or if you pass a proposition, then you will use the majority vote. Okay, so just like the idea in the apportionment method, when you say you are going to vote, this is not like you are electing someone. Okay, it could be that you are going to pass something like a proposition. For example, you are which Christmas amount for a given gift would win if this person A here suggests that the amount of the gift is 500 and the other is 300, and the other is maybe 200, then the one who will win uh, the said proposition, maybe you will use the majority vote or the popular vote. Okay, so there's a difference between majority vote and popular vote. But anyway, let's discuss that one later. So it's here. The first method that we're going to discuss is what we call the plurality method of voting. This is different from a majority vote or a popular vote. So a majority vote, what you need is this one: over 50% of the people voting must vote for the candidate. Meaning to say, if there are 100 people wants to pass a proposition or who wants that person to be elected, uh, if you are going to use the majority vote, then it must be that uh, 50 plus 1 or 51 people vote for that proposition. Okay, because it says here that it must be over 50% of the people voting must vote for the candidate. So if there are 100 people who will vote, then we have 50% of that is 50, and plus 1 we have, so more than 50. Okay, then that proposition will win. Okay, that's what do we mean by popular vote, by majority vote, I'm sorry. When you say popular vote, this is a kind of voting where uh, if that proposition have the most votes, then example, if you have proposition A, B, and C, if proposition A has most votes, then that proposition will win. That's the difference between popular vote and majority vote. Okay, so what is this the so-called plurality method of voting. So we have here the plurality method of voting. This is a kind of voting in which each voter votes for one candidate, and the candidate with the most votes wins. The winning candidate does not have to have a majority of the votes. So what does this mean? Let's have an example here. This one. So let me explain the definition, this definition here, using an example. So example number one, determine the winner using plurality method of voting. Okay, so this one, fans of the X-Men movies have been debating on an online forum regarding which of the films is the best. To see what the overall opinion is, visitors to the site can rank 4 films in order of preference. The results are shown in the preference schedule below. Okay, this one. This is what we call preference table or schedule. Okay, so let me explain this preference schedule. So what do we mean by a preference schedule? This one here. This one here. So let me give a meaning. Okay. Preference schedule is a list. No, it's not. It's a list. Okay, let me write it here. A preference schedule list the number of people who gave a particular ranking. Okay, this is the meaning of the preference table. So as you can see here, let me explain the meaning of this table. Okay, remember at the bottom here, 429. What does this number signifies in this table, preference table? So it means here that these 429 voters, okay, their preference is this column here. Okay, this column here. Okay, this means that for these 429 voters, for their when you say 1, this is the best. X-Men is their top 1. X2, which is X-Men Days of the Future Past, is their top 2. Okay, and their top 3 is X-Men First Class, and the last one is X2 X-Men United. For these 429 voters. Okay, that's what we mean by this preference table. This number here, 1137, their top 1 is the X-Men. This one here, this one here, this 129. This means that this is their top 1. The top 2 here is the X-Men Days of the Future. Top 3 is X-Men First Class, and this one X2 is X2 X-Men United is top 4. For this 1137, their top 1 is X-Men Days of the Future. Okay. Number 2 here is their top 2, which is X-Men. Their top 3 is X-Men First Class, and finally their top 4 is X-Men United. Okay, this is for this 1137 voters. For these 384 voters, their top 1 is X-Men, their top 2 is X-Men United, their top 3 is X-Men Days of the Future, and their top 4 is First Class, X-Men First Class. And finally, these 582 voters here, their top one is X-Men United, top 2 is Days of the Future, top 3 is X-Men, and top 4 is the X-Men First Class. Okay, this is what we mean, the meaning of this reference schedule. So all throughout, in this topic, we will be considering this kind of table. Okay, this is not the same as here in the Philippines. Okay, uh, here we use the majority vote or the popular vote. Okay, uh, maybe one day if you come back in this university, if the this pandemic is what they call this one will end, then you can test whether these four kinds of method in the future will be used in your study, maybe in your thesis, uh, yeah, or maybe if you want to know which soup is the best in this for example in Mus 1, uh, there are so many applications for this kind of methods of voting. Okay, but anyway, let's answer this one. According to this table, which X-Men movies would win using the plurality voting system? So let me recall the definition. It says here that each voter votes for one candidate, as you can see there. Every voters here, so there are 429 voters here. The voter here in this column, so voter number 1, 2, 3 up to 429. So for voter 1, this is his or her preference. Okay, 1, 4, 2, 3. Voter 2, the same until 429. The other voter here, this is his or her preference. Okay, so meaning each voter votes only once. Okay, and the candidate with the most votes wins. So what do we mean by this? And the candidate with the most votes wins. So we will be considering here the first place votes. Okay, so this phrase here, we will be considering the first place votes. Okay, first place votes. Okay, so that's what we mean by plurality method of voting. And also, let me have this is quite a remark here. It says here that the winning candidate does not have to have a majority of the votes. We will explain that later. Sometimes, if you use plurality method of voting, that winner does not have to win the majority vote. Okay, so let's try to answer now this what you call this one, this example. Okay, so to answer this question, let's have this color, maybe this blue. Okay, to answer the question, we will make a table showing the number of first place votes. Okay, for each movies. Okay, so don't worry, I'm going to fast forward this in making a table. Okay, so let's have here, let's say first that one. First is X-Men. We have X. Sorry. Let's have another color here. Maybe this green. X-Men. The second one is X2 X-Men United. X2 X-Men United. Third one is X-Men Days of the Future. Of the future past. Future past. And the last one is X-Men first place votes. Okay, so how do we interpret this this table here? So when you say you are going to get the first place votes, just look at the row. Okay, this row 1. For this row 1, okay, we have row 1. This is for the X-Men. Okay, and then look at if there's a first place votes, meaning there's a 1 there. Okay, so as you can see, we have a 1 here, 1, and also we have a 1 here. So for 1 here, there are 429 voters, and the other for 1 here, we have 384 voters. So we have to add them. So the answer is, we have here 429 plus 384. Okay, so get the value for that one. Where's my calculator? Don't know where's my calculator. Somewhere here. So 429 plus 384, the answer is 813. Okay, so that's 813. The second one is, when you are going to fill in this row here for X-Men, X2 X-Men United, just look at this row 2. Okay, and then look at if there is a first place votes. So there is a 1 here, as you can see here, there's a 1. So therefore we have a first place for votes for X-Men, which is equal to 582. Okay, so we have 582 here, 582. Okay, then the same also for Days of the Future, if there is a first place votes. Okay, so they here row 3. So row 3, so we have here first place votes, and then we have 113. Okay, there are 1137 voters here. Okay, so this is 1137, sorry, 1137 for X-Men first class. As you can see here, X-Men first class. Okay, there's no first place votes. Okay, there is no first place votes. Row number 4, you cannot see a 1 here, so meaning to say there's no first place vote, so this is 0. Okay, this is 0. So in this answer, as you can see here, the winner is this is the winner. Let's have this blue one here. Okay, this one, this is the winner. Okay, so don't forget to write the conclusion. Let me put here, because X-Men Days of the Future past, Days of the Future past. Okay, receive, sorry, receive 1137 first place votes, first place votes. This what I call this one, that type, this movie, this film. Okay, this film, this film would win the plurality method of voting. Okay, so this is how you are going to solve using the plurality method of voting. So maybe let's have one more example in just a moment. Okay. Okay, this is the promise example. Example number 2, the same method of voting. A company is planning its annual summer retreat and has asked its employees to rank 5 different choices of recreation in order of preference. So this is our preference table. The results are given in the table below. So I already discussed the meaning of this table. So let me recall with this voters here, these 10 voters here. This means that this is their preference. Okay, for them, this top 1 is the picnic in a park. Top 2 is amusement park. Top 3 is water skiing at a lake. Top 4 we have dinner cruise, and top 5 we have riding horses at a ranch. Okay, the same is true for 18, 16, 28, and 16. You can do the same analogy. Okay, the question is, using the plurality voting system, what activity should be planned for the retreat? Okay, so this is the solution. This one here. Okay, to answer the question, we will make a table showing the number of first place votes. Okay, for each recreation. Okay, so again, I'm going to make a table and then come back later. Okay, so that it will not waste us time. Okay, this is now the table showing the number of first place votes for each recreation. So let's go back to picnic in a park. So as you can see here, look for this row here and determine if there is a first place votes. We have 2, we have here and this one. So we have 10 plus 6. Okay, 10 plus 6. So we have 10 plus 6, we have 16. For water skiing at the lake, this part here, so there is a first place votes here. Okay, let's have this color here. Okay, so we have 18, 18, and then we have, how about for the amusement park? There is a 1 here, this one here, so we have 28. So let's try 28 here. 28. Okay, riding horses at a ranch. Let's try this column here. This one. This column here. So there is one. This one. We have 16. Okay, 16. Let's try 16 here. And then dinner cruise. So there's no one in this column. Okay, as you can see in this row, there not column, in this row there is no first place votes. Okay, this is 0, so the answer for this one is 0. Okay, so the winner is this value here somewhere. This is 28. Okay, this is the winner. Okay, so amusement park. So let's write the conclusion. Because amusement park receive how many? 28. Okay, 28 first place votes, then this type, no, not type, this recreation, this recreation, sorry, this recreation would win the plurality method of voting. Okay, so please do remember these two examples because we will be using this one to the other method. Okay, these two examples, example 1 and number 2. Okay, so for the second method of voting, which will be the Borda count method of voting, will be given next. Okay, for this second method of voting, this is what we call the Borda count method of voting. So what does this mean? It says here, it's each voter ranks all the candidates. That is, each voter selects his or her first choice, second choice, and third choice, and so on and so forth. If there are n candidates, remember, if there are n candidates, each candidate receives n points for each first choice vote, n minus 1 points for each second choice vote, and so on and so forth. The candidate with the most total points is declared the winner. So this is for the Borda count. So what does this mean? When you say if you have n candidates, example, if you have 5 candidates, okay, we have here 5 candidates, okay. So example for this particular voter, example for me, if I choose candidate number 5 as my first place vote, as my what they call this one, as my first choice, if that candidate number 5 is my first choice, then since there are 5 candidates, so the candidate number 5, since he or she is my first choice, then you will assign 5 points for him or her. Okay, for that second choice, then that point is 4 points. For the third choice will be 3 points, and so on and so forth until the last candidate, the least one. Okay, That's what we mean by Borda count method of voting. Okay, so let's have an example here for a illustration. The same what they call this one example as in example number 1 in the plurality method of voting. Here we will use Borda count. Let's see if we have the same winner. Okay, I guess the winner for the plurality method of voting is X-Men Days of the Future Past. Let's try the word count method of voting if still X-Men Days of the Future Past is still the winner using word count. Okay, so let's have the solution. Okay, we will use word count. How many, ask yourself, how many candidates? Okay, how many candidates? There are 4 candidates, okay, or 4 choices. Okay, so we have our n here is 4. Okay, our n is 4. Okay, so for example, this 429 voters. For them, 429 voters, for them, as you can see here, this X-Men will be given 4 points. X-Men of the Future Past will be given 3 points. This is the third choice. X-Men First Class will be given 2 points. And finally, this is the last rank. We have X2V, X-Men United will be given the what do you call this one? 1 point. Okay, so that's how you are going to give the points using the Borda count. Okay, so anyway, so using the Borda count method, each first place vote receives. Remember that this will depend upon the number of candidates. Okay, receive 4 points. Okay, 4 points. Each second place vote receives, sorry, this one here, receives with S 3 points here. Each third place receives 2 points, and finally each last place or fourth place receives 1 point. Okay, so this is the summary. For each film is shown below. Okay, so what are we going to do here? We have for X-Men, let's try this one. Let's try this color. Okay, X-Men. Okay, let's try to count the first place votes. Okay, first place votes here, second place votes, then third place votes, and then finally this is the fourth place votes. Okay, so let's try this color, maybe this one, this color here. Okay, let's try to count for X-Men. Okay, if he receives a first place votes. Okay, this one here, just look at this row here, row 1, there is a first place votes. Okay, this one here, first place, so we have 429 and 384. 429 plus 384. Okay, for the second place, we have a second place here, we have 1137. 1137. For the third place, we have also one here, we have 582. Okay, 582, and there's no fourth place. Okay, there's no 4 here, no rank number 4, so this is 0. We have here 0. Okay, so just count, just add 429 plus 384, we have 813. Let's try this color here, 813, we have 1137, 582, we have 0. So we have times here, multiplying. Okay, so let's try this blue color. So we are given 4 points here since we have a first place votes. So our first place votes will be given 4 points, as you can see here. For the second, we have 3 points. Third, we have 2 points. Okay, so this is 3, 2, 1. Okay, then sum, just sum it all. We have here, so the answer, let's have a total here. So 813 times 4, we have 3,252, and then 1137 times 3, we have 3,411. Okay, 582 times 2 is 1,582 times 2, 1,164, and this is 0. Okay, so add them all, plus 3,411 plus 3,252. The answer is 7,827 points. Okay, so this is for the X-Men. Okay, then do the same for X-Men 2 United, X-Men Days of the Future Past, and so on and so forth until X-Men First Class. I'm going to skip this one and then write it here, skip the video, and then come back later after writing these values here for the other 3. Okay, so that we will not waste time. Okay, I've already make a copy of what I did in the first computation, this one here. So let's now look at the row for X2 X-Men United. Okay, let's compute somewhere here, this one. So I guess the first place is this one, so 582. Second place, we have 384, 582, and then 384. Okay, 582, 582, 384, and as you can see, you have 0 first place votes. Okay, 0 third place, sorry, there's no third place. Then we have 2 fourth place, 429 and 1137. 429 here plus 1137. Okay, so let's compute using a calculator. We have here 582, we have 384, and then we have 0, and then 429 plus 1137. The answer is 1566. Okay, so this one is 1500. Sorry, let's try this black color here. 1566. We have 0 here. 384 times 3, we have 1152, and then 582 times 4, we have 2328. Okay, sum it all. 1152 plus 0 plus 1566. The answer is 5046. Okay, so that's for what they call this one, X-Men X2 X-Men United. Okay, so I'm going to fast forward this part here so that it will not waste again a time. So let me compute somewhere here. 1137. Let's 1137. Okay, there's here this 1137. Then we have second place 582 plus second place here 582 and 429. Third place, we have a third place which is 384, and fourth place, we have no fourth place, we have 0. Okay, that's for the X-Men Days of the Future. For the X-Men First Class, we have 0 0 0 for the first place. There's no first place, we have 0 0. Second place, we have 0 0. Third place, we have this one. So we have 429 plus 1137, and then fourth place we have 384 plus 582. Okay, so this is for this row here, X-Men First Class. So let's try to put it here, our computations. Okay, so let's write it somewhere. This is 1137. Just look at your notes. 582 plus 429, and then 384 here. We have 0 here. Also this one we have 0 0 1129 plus 1137, and then here we have 384 plus 582. So this is let's have this green color for uniformity. 1137, 582 plus 429. The answer is 1101, and we have 382 here, and then no, not 382, 384 here, and we have 0 here. So 1137 times 4, so we have 4,000. I'm here in my calculator. 4,548. 1101 times 3, we have 3303, and then 384 times 2, we have 768, and then we have 0 here. So you can add them all, plus 3303 plus 4548. So this is 8,619. Okay, so far this is the highest. So let's try this one. Here we have 0 0, and then 1129 plus 1137. So the answer is 2266, and then 384 plus 582. So we have 966. So 966 here, 2266 times 2, we have 4532. We have 0 here, 0 also here. Plus 966 is 5400. Okay, sorry. 5498. Okay, so I guess this is the winner. This is the winner. Sorry. This is the winner. Okay. We have here 7,827, 5,446, 8,619, and 5,498. So let's write the conclusion now. So X-Men, what do you call this one? X-Men Days of the Future Past. So X-Men. Okay. Days of the Future Past has the largest total score. Okay, by the Borda count method. X-Men Days of the Future Past is the what do you call this one, is the winner. Okay, just try example number 2. If still this the winner there in plurality method of voting is the same as the Borda count, for example number 2. So let's recall for our example number 1, who wins. We have, where's that one? Where's that one? The winner is the same. Okay, X-Men Days of the Future Past. The winner for the plurality is the same as the Borda count. Okay, so we have now a similarity, but that is not always the case. Okay, please remember that. So in the next lecture, we will be discussing the third method. Okay, just wait. Okay, this is now the third method of voting. This is what we call plurality with elimination. This method is similar to number 1. The difference is that we will do elimination. When we say we do elimination, when you are going to get the first place votes, the one that has the lowest score will be eliminated. That's what we mean by plurality with elimination. Okay, so it says here, let's all read this one. Each person votes for his or her favorite candidate, receives a majority of votes. That candidate is declared the winner. If no candidate receives a majority, then the candidate with the fewest votes is eliminated and the new election is held. This process continues until a candidate receives a majority of the votes. So it says here that we have to eliminate this one here, this one. So let's illustrate this method using an example we have here. The same problem as in the first voting and the second voting method, we will show by plurality with elimination who is the winner for this this example. So again, for the plurality method and the Borda count, the winner is the X-Men, this one, Days of the Future Past. So let's try with elimination. If still, the winner is this one here. Okay, so what are we going to do here? First is we have to, of course, put the solution. Copy first this problem. Okay, let's copy first this problem, and then put it here, somewhere here. We have X-Men, and then X2. Anyway, I'm going to fast forward this one here. Okay, X-Men United. First place votes. Okay, so we've done this already. First place votes for X-Men, we have 429. 429 here. This is the first place votes for X-Men. Okay, so 429 here at the bottom, and 384. 429 plus 384. 429 plus 384. 384 is 813. Okay, so we have here 813. Then for the X-Men we have here, so 582. 582. For X-Men Days of the Future, we have 1137, as you can see here. Okay, this one. And in the X-Men First Class, there's no first place votes, so this is 0. Okay, so what are we going to do here is we are going to eliminate. Okay, this one here, maybe let's have this color. What color do we have to use? Maybe this pink, this one. Okay, then this one here, this one will be, okay, eliminated. Okay, we will eliminate this one. Eliminate. Okay, so next is we have to re-rank. Okay, so when we are going to re-rank, since this one is eliminated, this one here, this one is eliminated, so we are going to re-rank the table. 1 will be fixed, 2 becomes 1, 3 becomes 2, and 4 becomes 3. Okay, it will move up everything. Okay, so here we have, let's try this color. So we have here X-Men. So since this one is eliminated, so we have here 1 is fixed. Sorry, let's try this color blue. 1 is fixed. 1 is fixed here. This will be, 2 is fixed, cannot move up to 1, but our 4 becomes 3. Okay, so our 4 becomes 3. This one here we have 1, 2. Let's fix that one. 1 is fixed, 2 is fixed, and we move forward to 3. Okay, and then finally this one here we have 1, 2, 3, the same. 1, 2, 3, and this one is 1, 2 here, and 3 here also. Okay, so this is the new table, and also the number of voters are the same. Okay, so again, let's look at here. So for the X-Men we have something here, this one. Okay, so we have 429 and 384. I guess they are the same. 813. 813. For X2 X-Men United, we have 582. Okay, 582. And then for X-Men Days of the Future, we have here this one, 1137. Okay, 1137. Okay, so we are going to eliminate X2 X-Men United. Okay, this will be eliminated. This is the one with the small value. Okay, 582. So for this, we have to eliminate this one here, and then and then we are going to re-rank it again. Okay, until only two are left. Okay, so that one. Let's continue. So before I'm going to write the last table, the question here is, what if there is a tie in here? Okay, if there is a tie, all you have to do is to eliminate those two. Okay, eliminate those two if there is a tie. Okay, and the winner is, example, if this is 582, so the winner is X-Men Days of the Future. Okay, so if there is, example, in this table here, if there is an equal value, like for example we have X-Men United is 0 also, then we have to eliminate those two. Okay, but what if all are eliminated? Okay, if all are eliminated, then there is no winner. Okay, so you cannot apply the what they call this one, the plurality with elimination method. Okay, so please remember that one. Okay, so let's make again a table for X-Men and X-Men Days of the Future Past. Okay, I think I missed something here, so let's make a table again. And one becomes will be fixed. Okay, so from here so we have 1 2. Okay, here we have 2 1. Okay, this column here, this row here is eliminated, so we have 2 1. We have 1 2, 3 becomes 2, so this is 1 2, and in here this becomes 1 and this becomes 2. Okay, so we have 2 1. Okay, so again, number of voters becomes 429, 1137, 384, and 582. Okay, so make the last table. Finally, we are done, almost done. So let's make this one is X-Men, and then X-Men the first place votes. Okay, so let's try this one here. We have, for X-Men, we have this one here, we have 1, so 429 and 384. I guess this is 813. Okay, 813. And this one here, we have 1137 and 582. Okay, 1137 plus 582, the answer is 1719. Okay, so from here the winner this is the winner. Okay, this one here. Okay, this is the winner. Okay, so let's put now the conclusion. So our conclusion, using let's have this one, using plurality with elimination method, X-Men, days of the future past is the winner. Okay, future, this one. Okay, so we are done. So as you have noticed, for the three methods, X-Men, days of the future past is always the winner. Okay, but this is not always the case. Please remember that. So for our next topic, we will be discussing about the last topic, which is the pairwise comparison voting method. Okay, so just wait. Okay, this is the last method. This is called the pairwise comparison voting method. Okay, this method is sometimes called to be the head-to-head method. Why? Because based on the, as you can see here in the title, we have pairwise. Okay, so you are going to take on this one to this one here, to pair. Okay, to pair every possible, okay, every possible candidates. Okay, so if, for example, here you have to pair X-Men and X2, X-Men United. So whoever wins this one receives 1 point. Okay, so if this is a tie, then he will receive, each of these candidate will receive 0.5. So this is what we call the pairwise comparison voting method. This is the most troublesome method because there will be many computations. Okay, but anyway, let's try to illustrate this method by answering this example. And before I will answer this one, this method also is what they call this one, part of the fairness in voting. Okay, so this is what we call the Condorcet criterion. Okay, so anyway, I will discuss that one later. So it says here that the candidate who receives the most points is declared the winner. So you have to pair every candidate. Okay, but remember that the candidate X-Men and X-Men United is the same as X-Men United versus X-Men. Okay, so first is we have to make a table here, but we have to make some note. Here we will create a table to keep track of each of the head-to-head comparison. Okay, before we begin, I'm going to put a note here. Note that a match-up between say this one here, between X-Men, example this one here, X-Men and let's say X2, X-Men United is the same as the match-up between X2 X-Men United and X-Men. Okay, we know that they are the same. Therefore, what we have to do is to in the table we have to shade the duplicates. Okay, so therefore we will shade the duplicate cells and the cells between the same candidates. Okay, because as you can see, you cannot head to head, or you cannot match up X-Men versus X-Men. Okay, so that's something crazy. That is not the proper way of solving. So this is shown below. So I'm going to pause for a moment and then come back later after making the table. Okay, okay, this is now the table. As you can see, do the same if you have a problem like this. If you are going to solve using the pairwise comparison voting method. So as you can see here, we are going to make a shade in the diagonal. This one here, this part here, this one also, this one here, and here also, because we cannot do a head-to-head match-up if they are the same. So X-Men versus X-Men is cannot be done. Okay, and also we have here X-Men versus this one here, X-Men versus X2, X-Men United is the same as X2 here, X-Men United versus X-Men. So we are going also to shade below the diagonal. Okay, so just give me time to shade everything here. Maybe this color here. Okay, this color is right. So it will take time to shade everything here. This one also, this one here, and so on and so forth. Okay, so just give me time. Okay, I've completed the shading, as you can see here. So let's move now to the first matchup. Okay, so let's have this first matchup. Here we have X-Men versus X2 X-Men United. So first matchup, first matchup. So we have here X-Men versus X2 X-Men United. So what are we going to do here? We have here first matchup. Let me put it here. X-Men, let's say X-Men was favored over X2 X-Men United on something there. And also let's have another color here, maybe this I think this blue. Okay, we have here X2 X-Men was favored over X-Men on, okay, that one. So what do we mean by this red color here? X-Men was favored over X2 X-Men United. So go back to your table. So let's wait for the program to respond. Just go back to the table and then look at the table, the row for this one here, the row for X-Men and X-Men United. Okay, so when you say X-Men was favored over X2 X-Men United, this means that with this circled here, this one, when you say X-Men is favored, look at the row at the column for X-Men and X2 United, X2 X-Men United. So from here, X-Men was favored. Let's say A here, this is B. A is favored over B. This one here also, A is also favored over B. Here we have, look at the rank, 1 4 2 4 1 2. So 1 is higher than 4, 2 is higher than 4, 1 is higher than 2. So all these three, this one here, A is was favored over B. But for this column here, the last one column, this one here, X2 X-Men, letter B is favored over A. Okay, so remember 1 4 2 4 1 2, so A is favored over B in this scenario. Okay, so but this last column here, B was favored over A. Okay, so meaning to say, these points here, these voters here, belongs to A, while 582 belongs to B. Okay, so that's how you are going to do the head-to-head matchup. So in here we have 429 and 1127, 137, 429, so 429 plus 1137, and where's that one? 384 is for X-Men, while X2 X-Men is 500 what's this one, 584. Just wait for the program to respond. 582. Okay, so this is 582. Okay, so the value here is, let's compute, 429 plus 1137 plus 384 we have 1,950, okay, votes, and here we have 582 votes. So the winner in this match-up, okay, X-Men versus X2 X-Men United, the winner is this one here. 90, this is the winner. Okay, so from here the winner, let's put it's this one here, X-Men. Okay, X-Men is the winner. Okay, so do the same for X-Men versus X-Men Days of the Future. So for the second matchup, okay, so maybe we have to wait for the program to respond again. Second match up. So we have X-Men versus X-Men Days of the Future Past. Okay, so in here, do the same, copy this word here, but replace this one. Okay, just replace this one here, this one, that one. Okay, just replace. Okay, the same computation. So let's do it again. This one here, X-Men was favored over X-Men Days of the Future Past on, and then let's see here, reverse, to the reverse, X-Men Days of the Future Past was favored over X-Men on. So just compute again, just go back to your table here, and then let's try to erase this one, let's erase this one, here, let's erase it again, and then let's compare. Okay, let's compare X-Men, this one here, and X-Men Days of the Future. So all you have to do is to compare this row here, this one, with these values here. Okay, that one, sorry. So let's wait again for the program to respond. We want to wait. Okay, so this one, compare this column here. Okay, that one. So from here, X-Men is favored over this one, Days of the Future 1, 2. So 2, 1 is X-Men Days of the Future was favored over X-Men, because most of these voters here are voted for this film first than the other one. Okay, the 1, 3 we have here, 1, 2, 1, 2, 2, 1, 1, 3. So we have this one is for X-Men, 3, 2. So this is for the Days of the Future. Okay, so these two values here is for X-Men, while X-Men Days of the Future is this value here. Okay, so let's put it down, 4, 2, 9, and 3, 8, 4. 4, 2, 9 and 3, 8, 4. 429 plus 384, and the remaining 4 here is 1137 plus where's that one, 582. So if you sum it up, so 429 plus 384 is 813, while the other is 1137, which is very clear, 582, that X-Men Days of the Future won already, 1719. So the winner is this one. Okay, that's the winner. Okay, you can do the same. Let's put it somewhere here. X-Men Days of the Future past. Okay, so do again for this cell here, this cell also, and so on and so forth, but I'm going to skip that one so that it will add time in this video. Okay, here is X-Men Days of the Future past. So clearly, as you can see here, we have 1, 2, 3. Okay, 3 points. X-Men 2 points, and X-Men First Class is 1 point. So clearly the winner is again the best movie in this problem is clearly the X-Men Days of the Future past. So therefore, by pairwise comparison voting method, X-Men Days of the Future past is the winner. So this is the best movie. Okay, so now after this discussion, we will be discussing about pairwise the fairness in voting. Okay, so let's wait. Okay, we are now ready to discuss the fairness criteria of voting methods. So the first one, there are 4 here. We have majority, monotonicity, Condorcet criterion, and independence of irrelevant alternatives. Okay, so for the first one here, this one here, majority criterion, the candidate who receives a majority of the first place votes is the winner. Okay, so meaning to say, if you are going to use a particular voting method, then if the winner is the same as the winner using the majority vote, then the that particular example or given does not violate the majority criterion. Okay, so let's try to illustrate this one by by answering this example here that I prepared. Okay, so and next we will be discussing maybe uh, the third one, which is very familiar, and then the fourth one before going to the second. Okay, this one here. So let's have an example here. Three candidates are running for mayor. A vote was taken in which the candidates were ranked in order of preference. So this is the preference table. The results are shown in this table below. So since here, I'm not going to solve this to solve this one. Okay, just do it at home, and then verify if answers. Let's try to put an answers here, which is different from solution. Letter A. Use the Borda count method to determine the winner of the election. So I've solved this already, and the winner for the answer for letter A is Stephen Hyde. Okay, so just use the Borda count method here. Remember that there are the n here is equal to 3, so therefore if you have the first place, you will give 3 points. For the second place, we have 2 points, and the third place we have 1 point. Okay, so the winner for letter A using Borda count is Stephen Hyde. So just solve it at home. So we have here letter B. Okay, let's solve this one. Letter B, majority. Verify that the majority criterion has been violated. So what does this mean? Meaning to say that we are going to, as you can see here, get the first place votes. Okay, so clearly using Borda count, Stephen Hyde is the winner. Okay, so get the first place votes. So let's have here let's say GL, John Lawrence, Marcia Besley, and Stephen Hyde. Okay, let's make a shortcut here. We have rankings. Okay, and then all we have to do is to get the first place, not rankings, but the first place votes. Okay, first place votes. Okay, so let's make a table here, and then somewhere here. Okay, that one. Okay, so let's calculate the first place votes. We have for John Lawrence, we have here 1, so 2,691. For Marcia Veste, we have 2,400. We have 1 here, 2,416. And Stephen Hyde, we have 237. Okay, so this is 237. So what does this mean? Why does it violates the majority criterion? Okay, since as you can see in the letter A, using Borda count, the winner is Stephen Hyde. However, if you get the majority of the first place votes, the winner is we have John Lawrence. Okay, this one here, this is the winner. Let's have this color here. This is the winner, this one. Okay, so the reason for this is Stephen Hyde receive the smallest number of first place votes. First place votes. So that is why it violates the majority criterion. Okay. So for letter C, here identify the candidate who wins all head-to-head matchups. Okay, so meaning to say you are going to use the pairwise comparison voting method. So I've solved this already. The answer for that one, just verify it at home. The answer for that one is John Lawrence. Okay, for the answer for letter C is John Lawrence. Okay, so verify that one at home when you study this example. Okay, so the question is, explain why the Condorcet criterion has been violated for letter D. So clearly, why is it that the Condorcet criterion is violated? It is because, as you can see, in using Borda count, the winner is Stephen Hein. But using the pairwise comparison voting method, the answer is John Lawrence. Okay, so what happens here is that if you look at the definition of the Condorcet criterion, it says that a candidate who wins all possible head-to-head matchups should win an election when all candidates appear on the ballot. Okay, so if the winner is Stephen Hyde, then it will not violate the Condorcet criterion. So the answer for letter D is here. Let's put it here. So verify this one at home. Verify home. Okay, so the candidate who wins all head-to-head matches does not win the election. Okay, this candidate here is Stephen Hyde. Okay, Stephen Hyde. Okay, so but the winner for pairwise comparison is John Lawrence. The winner for the Borda count is Stephen Hyde. Okay, so it must be the same in order for the Condorcet criterion will not be violated. Okay, so letter E. Letter E we have here. If Marcia Besley drops out of the race for mayor and voter preferences remain the same, so these preferences remain the same, determine the winner of the election again using the Borda count method. Okay, so the winner for this one, for letter E, is John Lawrence. I calculated this one already. The answer is John Lawrence. Okay. Letter F. In letter F, you are going to explain why the independence of irrelevant alternatives criterion has been violated. So if we go back to the definition of the what do you call this one, the independence of irrelevant alternatives, it says here, if a candidate wins an election, the winner should remain the winner in any recount in which losing candidates withdraw from the race. So as you can see here, in this example, Marcia obviously drops out of the race for mayor. So again, calculate using board account. Uh, the winner is should be Stephen Hyde, but the winner for letter E is John Lawrence. So maybe we can verify it. Let's have a solution. Maybe a solution here. This one. Okay, solution for letter E. Okay, so I will make a table and then come back later after making it. Okay, so this is now the table that I've made. So let's go back to the given. Okay, so remember it says here that Marcia, let's have this one, Marcia drops out. Okay, drops out from the race. So meaning to say we will delete Marcia. Okay, but here it says here that a voter's preferences remain the same, so it doesn't change. Meaning to say this is 1 2, then this becomes 1 and this becomes 2 here. It doesn't change. Okay, so the preference is the same, and here we have 1 here and this is 2 also here. Okay, so 1 2 2 1 2 1. Okay, so that's what we mean by the voters preference remain the same, although we drop out Marcia Besley. Okay, so let's go back to our table. We have 1 2, am I right? 1 2 2 1 2 1. Okay, so let's go back again. We have, let's verify 1 2 2 1 2 1. Okay, 1 2 2 1 2 1, and let's use the board account. Okay, using board account, let's have GL here. So for the, let's compute for the first place votes. First place votes, and then we have second place votes. Okay, so let's have here, as you can see, for GL we have 2,691 we have here, and then for second place we have 2416 plus 237. Okay, so what are we going to do here? We have 2,691 times 2, and then how much is 2416 plus 237? The answer is 2,653 times 1. Then we have 2,653, and then 2691 times 2, we have 5,382. So sum it up, plus 2653, the answer is 8,035. Okay, that's for GL. How about for Stephen Hyde? Let's try this color here, Stephen Hyde. Okay, so first place votes, second place votes. So let's calculate again. So for his age, we have Stephen Hyde, we have this one here, first place, we have 2416 and 237, and then for second place we have 2691. So the answer here would be 2691 times 1. We have 2691. And how much is 2 4? This is 26 2416, which is 2653. Okay, so 2653 times 2, we have 5306. We have 7997. So this is the total. Okay, so this is the winner. Okay, that's the winner. So I verified that this one here is correct. Okay, so let's go back to our question. So as you can see here, if Marcia Besley drops out of the race for mayor, then John Lawrence win the election using the Borda count method. So explain why the independence of irrelevant alternatives criterion has been violated. So it's clear, if someone drops from the race, the winner should remain the winner. So in example in A, the winner is Stephen Hyde, but in E, the winner is John Lawrence. So this is the reason why the independence of irrelevant alternatives criterion has been violated. So let's put a conclusion here. Letter F. Let's have this color. Letter F. Okay. So the candidate winning the original election, which is in letter A, which is Stephen Hyde, okay, did not remain the winner in a recount after losing candidate withdraw from the race, okay. So I guess we explain the majority criterion, the Condorcet criterion, and also the independence of irrelevant alternatives criterion, this one here, okay, this one. Okay, so what remains is this criterion here, monotonicity criterion. So I prepared an example here, this example one here. Let's try to illustrate this criterion. So it says, if candidate A wins an election, then candidate A will also win the election if the only change in voters' preferences is that supporters of a different candidate change their votes to support candidate A. So what does this mean? This is very important. I'm going to put a line here. If the only change in voters' preferences is that the supporters of a different candidate change this one, their votes to support candidate A. Okay, so what does that mean? Let's have an example here. Maybe we have to wait for the program to respond. Okay, I have here an example to illustrate the monotonicity criterion. Okay, so it depends upon the given. Okay, so here, show that using plurality with elimination violates the monotonicity criterion. So in here, this example, this is the preference table. Using the preference table, you can verify it at home that the answer for letter A is gamma. Okay, gamma wins the election. So you can verify this. Okay, verify this at home. We will try to solve letter B. So what does this mean? Suppose that 10 people who voted for alpha first and gamma second change their votes such that they all voted for alpha second and gamma first. So first is look at the example, take the question. It says here that in the preference table, locate those 10 people who voted for alpha first and gamma second. Okay, locate that one. If you cannot find it, then the question is wrong. Okay, so as you can see here, we have this one here, 10, and it says in this given that alpha first, this one here, alpha first, this one, alpha first, alpha here first, and gamma second. Okay, so this one here, gamma second. What are you going to do is to change their votes such that they all voted for alpha second. So meaning to say, the first here will be second, and the second here will become first. Okay, so that's what we mean by monotonicity criterion. You are going to show using plurality with elimination that beta will now be elected. So in the first, using plurality with elimination, the winner is gamma. Okay, gamma is the winner. But then after they change their preference, their votes, okay, beta now wins the election. So if that's happen, then the monotonicity criterion will be violated. Okay, let's try to solve it. Maybe in this area here, let's have a solution somewhere here. Okay, so the table now becomes this one. This is the new table for letter B. So we have, let's denote alpha by this one. Let's say A, B, and C. Okay, G for gamma. Okay, this one here, that one. Okay, so this is the rankings. So this is now the new ranking. Okay, we have 4, 1, 2, 3, and 4. Okay, that's one. And then let's try this color blue. So we have here 2, 3, 1, the same, 3, 1, 2, and then 1, 2, 3. Okay, and we have 3 here. Let's try another color here. Let's say red. We changed that one, the original, because of the problem in letter B. We have 2 here and 1 here. So remains the same. We have 25, and then 30. So let's wait again. So we have 25, 20, 16, and 10. Okay, so we are going to use plurality with elimination. So from here we have to solve it this way. We have A, B, C, then we have first place votes. First place votes. So here. Okay. And then let's look at the first place votes for alpha. We have 16 here. Okay, we have 1 here, so we have 16. So 16, and then 1 also here for beta. We have 20. We have here 20, And then gamma, we have 25 and 10. We have 1 here and 1 also here. So 25 plus 10, so we have 35. So we are going to eliminate alpha. Okay, so alpha will be eliminated. So let's wait for the program to respond. Let's have here highlighter. So we have to eliminate this one here. Okay, and then let's put somewhere here eliminated. Okay, so let's make again a new table for beta and gamma. Okay, so we have beta here and gamma. Okay, make a new table, and then we have rankings here, rankings. So we have to change. Okay, so we are going to eliminate this one, that one. So 1 here is still 1, but 3 becomes 2. Okay, so we have 2, sorry, let's wait for the program to respond. Let's go back. Let's have this one. Okay, we have 2 1, and here we have the same 1 2. 2 becomes 1, as you can see here, 2 becomes 1 and 3 becomes 2. Okay, so we have 1 2, and here we have 1 is also 1, it will not become 0. 3 becomes 2. Okay, because there are only 2 candidates, 2 1. So who's the winner? BG, using plurality with elimination. First place votes. Okay, so let's have this color here. We have 25, 20, 16, and 10. Okay, so here we have for beta, as you can see, we have a first place here. So 20 plus 16, so 20 plus 16, which is 36. But for gamma, we have 25 and 35. Okay, 25 plus 10, which is equal to 35, sorry. So the winner here is beta, sorry, beta. Okay, so as you can see, beta now wins the election, while in letter A, gamma is the winner. Okay, so they changed their votes from alpha first to gamma second to alpha second to gamma first. So this violates the monotonicity criterion. So I'm going to put an explanation here. So the answer here is that, okay, the result the result violates the monotonicity criterion because gamma who won the first election loses the second election, even though even though gamma receive a larger number of uh, first place votes in the second election. Okay, so that's the reason why the monotonicity criterion is being violated. Okay, so finally, the last topic is we will be discussing the Arrow's impossibility theorem, which is similar to the Valensky-Young impossibility theorem. Okay, so I'm going to come back after writing that theorem. Okay. Okay, this is the last topic for the part 2 for voting. We have the Arrow's impossibility theorem. This is what I told you, that this is similar to the apportionment method, where we discuss the Valensky-Young impossibility theorem. It says here that there is no voting method involving 3 or more choices that satisfies all 4 fairness criteria. Okay, so you cannot find any example that will not violate the all 4 fairness criteria: the majority criterion, monotonicity criterion, Condorcet criterion, and the last one. The last one is the independence of irrelevant alternative criterion. Okay, so what does this mean? This means that we cannot. This means that none of the, none of the voting methods that we use, that we have discussed earlier, is fair. Okay, this is what we mean by this theorem. Okay, and not only that, we cannot also construct a fair voting system for which 3 or more candidates for 3 or more candidates. Okay, so that's what we mean by this theorem. So I hope if ever that you can find it, you can find an example, then of course you will be renowned as you disprove this theorem. Okay, so that's all for this discussion. The next part will be the weighted voting system.